Hello, Sören.
Hello, Peter.
Perhaps you would like to introduce yourself and then start with your presentation.
Yeah, sure.
Thank you.
I'm a project consultant for building technology in the very north of Germany, and I work for about 5 years at GEZE. So welcome to BAU Online and welcome to the presentation of healthy indoor climate and control through natural ventilation. Let's first look at ventilation itself and why ventilation is so necessary, especially in the current situation with the worldwide pandemic. We all know that ventilation is very important to improve indoor air quality, and it's important for the well-being of occupants in a room or a building. There are several factors which can affect indoor air quality, and I'd like to look at some examples with you. Let's have a look at the left-hand side. You can see VOC, which stands for volatile organic compounds, with evaporations from carpets, technical devices, furniture, paint, and so on. And if you stay in a room for a longer period of time with a high VOC concentration, it gets dangerous if you stay there for a longer time. There are other factors like aerosols and CO2, which you can see here, which you can see almost every day in media. We are talking about aerosols and CO2. I'd like to look at these two factors, which are very important for indoor air quality, in the later slides. In addition to these factors, we have, for example, humidity or temperature. If you think of a hot summer day, for example, you want to cool your room down during the night and want to do an air exchange. So temperature is also important, like humidity, and you want to get the steam out of the room. So let's have a look at the main tasks of ventilation systems or ventilation systems itself. What should they do? They should provide an improvement of indoor air quality. They are discharging high thermal loads, like temperature, for example, humidity, and very important pollutant concentrations, like aerosols and CO2, for example. So what should they do? They should do an air exchange in the room and thermal air treatment, like you can see in this picture below. So the classical way, we want to get fresh air in and want to get the stale air out to ensure an acceptable indoor air quality and do it as energy efficient as possible. But the people themselves, so we, are very important for indoor air quality as well. Because think of a full office with many people in it. Okay, in the current situation, this is not possible. But think of it, maybe the air quality is not the best if in a full office with many people and you have no ventilation, no windows are opened. We all know this situation. Because every one of us is exhaling carbon dioxide. And our own bodies rise the room temperature due to our own heat emission. And of course, aerosols are very important for indoor air quality. So what happens now when the CO2 concentration rises in a room? It could lead to disorders of well-being and impaired performance. So it could get dangerous if you stay in a room for a longer time with a high CO2 concentration. But also temperature, aerosols, smells, and so on are very important to this, because this is correlating directly with the CO2 concentration or with the rise of the CO2 concentration in a room. So we can say that the CO2 concentration is one of the key parameters for assessing indoor air quality. CO2 is measured in ppm, which stands for parts per million. If you look at the right-hand side, you can see different levels of CO2 concentration. A red area, a yellow area, and a green area. So you can see at about 1000 ppm, this is a good level for CO2 concentration, 1000 ppm or better below. And if you stay in a room with a high CO2 concentration of about 1500 or higher than 1500 for a longer period of time, this also is not the best to do. So we can conclude that fresh air is very important to lower the concentration of pollutants, and so it reduces also the risk of illness according to the current situation. And if we look at ourselves, it extends also our own performance for working, for example. Let's have a look now at the current situation. We all know that SARS-CoV-2 or COVID-19 is mainly transmitted via droplet infection. We know this because we hear about it every day, and the current knowledge of science is that it's mainly transmitted via droplet. You can see in this picture, or have a look at this picture at the left-hand side of the picture, where you can see the two people and the recommended distance we have to keep to each other in these days of 1.5 or 2 meters. We all know this distance because the risk of getting ill through coughing, for example, we have to keep this distance, and the bigger droplets fall down in an area of about 2 meters. So this is a recommendation to keep the distance of 2 meters. But this is not enough. We know, looking at current studies, that we also have, for example, while speaking, every one of us is exhaling very small airborne droplets, and these small airborne droplets stay in the room and they float across a much larger area or distance than the 2 meters. So if an infected person is in the room, you have no ventilation in the room, so the risk of getting ill is much higher, even over the 2 meters of distance. So it's very important to use fresh air. Let's have a look at case studies in schools. We can see a significant increase of CO2 concentration during the lessons, so during 45 or 50 minutes. You can see this in this chart. I like to explain this chart. Let's have a look at the line which is rising up and fall down, rising up again. This is the CO2 concentration which is measured during the lessons, and you can see at the beginning of the lessons the CO2 concentration rises up to 2000 ppm and drops down during the breaks, for example, if we are doing burst ventilation with a high air exchange. So, as we have learned before, 1000 ppm is a good level of CO2 concentration. This is difficult to reach because if we want to reach this level of 1000 ppm, maybe we have to open the windows the whole time, so this is not possible. But we can lower the CO2 concentration in a massive way, which you can see here in the blue line. So, we have to do time-based ventilation, for example, during breaks, and it's very important to do demand-based ventilation in addition to time-based ventilation. You can see the CO2 concentration is much lower than the gray line. So how can we solve this? For example, using monitors, they are measuring the CO2 concentration the whole time, and the goal is that we can start an early air exchange and regulate, for example, the ventilation duration. And also very important, we should make this process as energy efficient as possible. So for example, we just open the windows when it's really necessary. Let's have a look at systems and solutions. Which you can see here, we have the possibility to open the windows by hand manually. This is the easiest way to do this. We can use some devices, physical and visual cues to determine indoor air quality and go to the window and open it, for example, every 20 minutes. There's a problem because windows have to be opened promptly. We have to go to the windows, not 5 minutes later. We have to go to the windows promptly and open it. Because you've seen before, the CO2 concentration rises up to critical levels, so we have to go before reaching critical levels and go to the windows. And during lessons, for example, it could get interruptions or restlessness and so on. There's also maybe the risk of getting smear infection if different people go to the window and open the leaves. And also you have to look at the CO2 concentration the whole time. So the teacher, for example, has to look at the CO2 concentration, go to the window, open it and close it. So how can we do this in a much smarter way? And very important, smart doesn't mean only technical in this case. We also want to say we have the possibility to install demand-based ventilation systems, for example, in existing buildings. It's very easy to install in existing buildings. So this is also smart that we have easily the possibility to have a good solution for demand-based and also time-based ventilation. Using, for example, automatic window drives. You have windows, and we have the possibility of using different types of window drives to automate a window. And if we combine this window drive with a CO2 sensor, for example, or a temperature sensor, we have a simple, easy solution, and we can scale this up from a small solution to a bigger solution, for example. So the CO2 sensor is connected to the window drive, and intelligent communication between the two devices. We have the possibility that the CO2 sensor communicates to the window. We have a critical level of CO2 concentration, and now the window will open or close. Of course, it's very important to look at the weather situation, and you can integrate, for example, weather stations, and the weather stations can override the automated function if the weather turns bad, for example, if it gets rainy or stormy, for example. This sentence you see at the very beginning of the presentation, so ventilation can help to improve the well-being of occupants in rooms or building. We can conclude now that we have two factors to look at. We have the time-based ventilation. If you look at education buildings, for example, during the breaks, to do an high air exchange. This is very important, for sure. And in addition to this is very important. Remember the blue line, which you've seen before, to do the sensor-based or demand-based ventilation. We have the advantages that we have a measurement of the actual values in the room, and the windows are just opened when it's really necessary. If less people are in the room, maybe the window don't have to open very often, for example. You can adjust it very easily in the system, and you have the possibility also to save energy. There are different areas of application for this, like we have talked about education, office, healthcare, sport and culture, for example, and also hotels, restaurants and leisure. I'd like to look at a more technical detail for the education buildings, but it also fits perfectly to all the other areas of application. If you have a look now at this small picture, you can see a classroom, for example, and you have windows in the classroom, and we want to do an easy solution doing burst ventilation or time-based ventilation. We just have to install window drives, which can be different types of window drives. For example, if you look at GEZE, we have the GEZE IQ window drives. You can easily install these drives, and using, for example, ventilation switches, and you can override the automated function and manually open the window drive using the ventilation switch. It's very important. You can see this small signs next to the window, possible danger zones. If you have windows, or in the case you have windows where you can easily grab in. According to a European Machinery Directive, it's important to secure these windows. We have different possibilities for safety devices like contactless laser scanners, for example, or safety edges. And if you want to expand this system, doing the demand-based ventilation, doing tilt ventilation, for example, during the lessons, to get continuous supply of fresh air, you can see that the picture is getting bigger. But I'd like that you look at the classroom itself. You just look at the classroom, we can see that just one device appears in addition to the window drive. So this is the small solution I've talked about before. We can see a window drive and a CO2 sensor, for example, and these can communicate in an intelligent way using KNX. We use KNX, or KNX is an open standard for building automation, and you can find KNX in many existing buildings, for example, for intelligent communication or controlling heating, lights, shading system and so on. And all these devices can communicate directly in an intelligent way. So for example, the window drive opens the window and the heating cools down. We also have the possibility, if you look at the right-hand side of the picture, to use weather stations if the weather turns bad, like I said before, or if we have bigger solutions and want to monitor all this or measuring all the different systems like heating, lights and so on, we can integrate our system very easy to system integrators using a KNX connector. Or KNX control panels, we can, for example, integrate these panels to use the current status of the drives or control different scenarios. Also, night cooling is very important, and you can also do night cooling, of course, using this system. And you have, for example, the possibility to using sensor and time-based ventilation. For example, during to do a night cooling at 2 a.m. to 4 a.m. the window will open, but you have a target temperature, and if the temperature falls below this temperature, the window will close. There are different possibilities of drives according to your situation at the window. For example, using chain drives, we very often use chain drives because they are very small and very easy to install, and they are also very silent when they open and close the window. They are perfect for ventilation scenarios. And if you look at the right side, you can see the GEZE F1200 Plus. This is a very new device. And if you have booked the live presentation at GEZE, I'd like to present you the F1200 Plus live. This is a fully automated turn, tilt and locking device. Also for bigger facade elements, for example, and heavier windows up to 200 kilograms, for example. If you'd like, this would be nice if you look at this at the live presentation. So I'd like to say you many, many thanks for your attention. Thank you very much and stay healthy. And now I'm looking forward to your questions.
We are now at the end of our lecture. Thank you very much, Søren, for the interesting presentation. It seems that window automation is the most reliable possibility to get fresh air in rooms.
For sure, yes.
Yes. Thank you. Let's look together to the questions from the Q&A function. There's the first one is the question, can a GEZE ventilation system be retrofitted in existing buildings? Søren.
Yes, for sure. This is also one of the big advantages of the system. Like I said before, we can install it also in existing buildings for sure, using small solutions or bigger solutions. And it's very easy. This is one of the big advantages, to install these systems very easily with, like you've seen before, a window drive and a sensor, for example, for a very small solution to install this in existing buildings. Yeah.
Okay. I think it's a huge benefit, huh?
Absolutely. Yeah.
Okay. Okay. The next question is, are air purifiers not sufficient for a good indoor climate?
This is a good question because the science is talking about this a lot of air purifiers. So air purifiers, we can say, according to current studies, that air purifiers are also very important. So using air purifiers, it's okay, it's good to use them. But if you look at the current situation in the studies, we can say that fresh air is very important. We need fresh air. And in addition to this, using air purifiers, it's okay, of course.
Okay. Can I also purchase the complete system from GEZE? Is it possible?
Yes, it's of course possible. We can offer you the whole system. We can offer you the sensors, the window drives for sure, and the projection. It's no problem. But we also have the possibility, if you have existing installations, for example, using KNX or different systems, we can integrate our system using KNX connectors to integrate in the systems, or to system integrators. Very easy to install. No problem, Peter.
Okay, thank you. The next question we see here is, does GEZE have the right solution for every project size? Okay, from small to huge or big projects?
This is also no problem, so we can scale the systems from a smaller solution to a bigger solution. So talk to our experts and they will help you to find the perfect solution for you. Yes.
Okay, perfect. Sounds good. Which ventilation drives does GEZE offer, and which drives are optimally suited? We have heard about that, I think.
Yes, so according to your situation, we have different drives. So if we look at this fair now, maybe we should look at the F1200 Plus. This is our very new device, which can be used for even bigger elements. Like I said before, up to 200 kilograms or 3.5 meters of height. So it's perfect for ventilation scenarios at office buildings, for example. It's also very silent, and also chain drives, for example, which are very, very often used for ventilation scenarios, fits almost to every window. So I'm sure GEZE will have the perfect situation or the perfect solution for you.
Perfect. Okay, that was the last question. Thank you for the questions.